Hey everyone, welcome back to class. So in the last lecture, we talked about the object orientation of R and the basics of using functions, right? So we're in a R Markdown file. We know it's an RMD file because of this little left-hand corner. There's a little white piece of paper and the RMD logo. So we know we're in an R Markdown file. We're in the correct project up here in the upper right-hand corner, right? It's PLS 3055. If you haven't done that yet, it's not mandatory, but I do recommend you setting a project. We showed how to do that in the last video. And you should have a b-ball lecture _student that you've downloaded in order to kind of follow along with me. And you should be working and adding code in there. Up until this point, we've created the b-ball data set. We've created this height one as well. And then we've also added points and height to it. And so at this point, we've looked at b-ball, right? So I can run this line of code, command return, on just the written version of b-ball, and I can see that I've made this beautiful data set, one column for points, one column for height. Those are our two variables. And we can play with that a bit more too. So anytime you see this hashtag in an R chunk, right? So remember, we're in the world of our Markdown files. And so our code is going to come inside these curly brackets and apostrophes. Anytime we see active R code with a number sign in front of it, that means something's commented out, because I don't want to knit the R Markdown file with that. So the same thing goes for anything I don't want to run every single time. So I've commented out the install because we don't want to install every time. So view is a special function that allows you to actually open the data set a bit more concretely. So I'll show you here. So if I click view, it's actually going to open it up in a viewer pane. And I can open up b-ball this way. I can also open it up by clicking here. So view is a special function. So when you have a big data set, you may want to use view, but you don't want to knit with view. So that's the only reason it's commented out, but there's a few different ways that we can look at our raw data. We talked about looking at the tail and the head. Those functions give you the front and the back end of your data to make sure everything looks right. The first argument is the data itself. The second argument is how many you want it to output. So make sure, and the order does matter in all of these functions, right? So functions are just going to be a set of commands that enact some sort of particular action that's set forth by that function. So the head function contains commands to return the first 6 by default. If it's not the first 6, because we've specified, it'll be whatever you specify. So we have the head, we have the tail, great. So we know what our data set kind of looks like. How are some other ways we can describe the dimensions of our data? So we're going to want to really know what our data looks like before we play with it. And so we maybe want to know the dimensions. So what are the dimensions of b-ball? So this is using the dim function. So the dim function, when you input a data set, will give you two different things. It'll give you the number of the observations, and so the number of rows, and then it'll also give you the number of columns. So you can see that in a few different ways. You can also see that over here on the right-hand corner, 14 observations with 2 variables. So there's a few different ways you can get at the dimensions, but that's really helpful. We can also look at the column names. So that's the column names function. Again, you should be pausing in between and writing all of this code along with me. But the column names function is going to essentially just return to you all the different column names in your data set. The call names, I use that a lot when I'm trying to figure out what different options I have in a data set, especially if in the viewer it's so big, it's hard to scroll through and see. Call names becomes really helpful. So pause, hopefully right here, do dim and column names, and then we'll move on to class. So class is a function that tells us what kind of object we have. So the class function in this case, the class function, if we use the first argument, if we select out of b-ball the points variable, we see that points is numeric, right? So that's our interval ratio type variable. So the class function, you're going to select out of class the variable that you want. Remember that the select is the $, and these have to be all flush run together. If you put a space, it doesn't run. It did run in that case, but just make sure that all of this stuff stylistically is run together. There's going to be a few cases where you can't put spaces like that. So For class, we know it to be numeric for points. And then what if we wanted to know the class of the height variable? Well, that's a character, remember, because height is actually just short, tall, right? So this is technically a categorical or character, or in our particular cases for this class, it's a nominal variable. You could also probably make an argument that it's ordinal because short is less than tall. But any of those kind of work within this framework of R, right? Because R is going to treat all of them as character. It's not going to know the inherent difference, especially if it's text like that. So we know we have one nominal and one character. So say we only wanted to look at one subset. So make sure you pause at this point, get class done. So say we wanted to look at only the short players and see how many points they scored. So I can think of a world where maybe you are an analyst studying a basketball game and you want to know if there's any relationship between height and points. So we can start to kind of play with this idea of description and looking at our data set to see, kind of just eyeball what's happening. So we're going to create an object, right, called short folks. Remember this, this arrow is going to create an object for us. And we're going to use the subset function. So the subset pulls out the values that we want, the observations that we want, if it meets a certain criteria. So the first argument is the data set that we want to address. So b-ball is where we're at with that. And then we're going to select out the value that we wanted the observations to isolate. So say I only want to look at short players, which means I only want to look at people where height is exactly equal to short. So when you're in R, when you want something to say exactly the same as or only the same as, we're going to use the double equal sign. If you put only one equal sign, it won't work. It has to be double equal sign. So we want to look at the section of the b-ball data set with where height is only equal to short. We don't want to look at tall people. We're going to use the subset function, again, that has two arguments for the data and the criteria we want to use. Remember to put the short in quotation marks. And if we run that, command return, and then we look at short folks, we see that we get an object that has all 7 of the values for short, and it gives us the point values that they had. So we can see then at this point that it looks like short people are not returning a whole lot of points. If we change that to tall, so see, it's like the range is between 3 and 9. So it's a range of 6. If we look at tall and say we wanted to just change this, so make sure you've paused it and done short first. So say we wanted to look at the tall folks, command return. We see that the tall folks are on average, at least it looks like, scoring a lot more points than the short folks. Super interesting. Okay, so now we can kind of look at, this should be descriptive statistics of our data. So say we wanted to just know the average amount of points for any of our heights, right? So we just want to know the average amount of points. We go back to this mean function. Remember, we've looked at this before in our last set, but I want you guys to be able to do this now. So if we look at the mean, the average number of points, it's 10. So if we wanted to, we can create an object that says the average points. We're going to create an object of that. We're going to select this. We'll just say here. So now we have a new object that's called the average amount of points, and that stores the value 10, which is our average points. So say we maybe wanted to do the median number of points. We're going to create an object again. Let's do median points. And then let's do the same thing. Again, we can do the median and we can do the mean because it's an interval ratio or numeric value. And so we can actually meaningfully derive the mean and the median. So the median in this case, when we run it, is 10. And in this case, the mean and the median are the same. Okay, so we also can get all of this through the summary stats, which helps us out a little bit. So instead of, we'll skip this mode section for a second. You can go straight to summary if you want. And you can get all of these values with one function. So the summary function, if you select out that same kind of variable notation in the argument, so bball $points, it'll run all of that for you, and it'll give you the median 10, the mean 10. It'll give you the max and min, which allows you to decide the range. So the range in this case, so if I wanted to write out what the range is in the code, the range would be 18 minus 1, which is 17. So R actually works just like a straight calculator too, if you want. And so you can just do 18 minus 1, and it'll give you the value there. So let's go back to our summary though. So anytime I just click on it and you see that it pops up, that I'm command returning on that line, you can either, again, double click and highlight it, or you can just put your cursor on it and run. Either one works. So we know our range is 17. And then we also have this information on quartiles. So quartiles essentially say, for the first quartile, 25% of the data falls below 5.25 points, and 25% of the data falls above 14.75 points in the third quartile. So first quartile is below, third quartile is above, and it does give us some representation of spread moving forward. Okay, so say we don't have a interval ratio variable, we're going to start to actually move into the world of functions to get the mode. So we're looking at this section of code 125 through 130. And I'll walk you through the basics, but we're going to create a function called getMode. It's going to use this function notation to select out the unique values of V, whatever V ends up being, right? So that's going to be our input on the other end. And then it's going to find which one was the max number of V's and create, it's going to use the tabulate function to find that. Now, this is much more advanced than you guys need to know. So what I'll probably do is copy and paste this function into the actual module so that you guys don't have to handwrite this. So when you get to this point in the video, just make sure you go back to the module and copy and paste this. But we're going to use this new function that we made, and you need to run this function every time you open up R again, especially if your environment is clean, because it won't recognize that it's in there. Because this is not a part of base R and not a part of a package, right? We've actually created our own function in this case. It gets the mode. So this get mode function, if we wanted to use that for bball and height, right? Because it's a character nominal / maybe ordinal if you wanted to make the argument. You use the get mode function. I gotta run it. So run the function, use get mode. The mode is short. Now, we know that there's 17 short and 17 tall, so it's just going to pick the first one because they're both the same. But if they were uneven, it would pick the modal one, right? So that's the get mode function. Remember, this will be in your module. But that's how we can run descriptive statistics in R. I think a lot of times you'll end up running the summary function, which is great. But make sure you pause at this point and have all of this written down and maybe some notes, right? If you want to write some notes, you can comment them in here, notes in here, so that if it's commented out, then it won't run it, right? So you use the number sign. You can also, whoops, let's make that a little bit clear. I can also write notes here because it is in the text part of my RMD file. So you can write notes down here. Remember, if you're in the text section and you see these number signs, it's because it's creating a heading. And then the number sign here inside the R chunk is to comment it out. So they have kind of a dual purpose in the RMD file. Okay, so we're going to get into a little baby bit of graphing to start. Just so I want you guys to have some exposure to the understanding in this framework of it. But we're not going to actually expect you to fully understand the all of the stuff that's going on here. But I want you guys to start thinking about the fact that we have numbers, we have descriptive statistics, but they can be hard to interpret on their own. And a common way to make these numbers a bit more meaningful is graphing. So because we have one nominal and one interval ratio, we can do a box plot. We'll go into a little bit more detail about the kinds of variables that, or kinds of plots we can use based on the sort of variables we have. So that's where it gets back to needing to know your level of measurement, again, in order to properly pick the right plots. But because we have, let's say in our language too, a character and a numeric, then we can go ahead and use a box plot. So we're going to put our dependent variable on the left-hand side, so that's points, and our independent variable on the right. So we believe that height affects how many points somebody has. So on the left-hand side, let's write some notes. The left-hand side of the tilde is going to get our dv, what is being affected, and the right-hand side gets our IV, the cause. Okay, so we think that height is causing points to change. So that's our first argument in the box plot function. And then the data is going to be a separate argument. So we're going to say data equals b-ball. Because we're not doing exactly equal to or selecting something out, we can just use one equal sign here. Pause here, write it out. Okay, so when we run it, it's going to look something like this. So we get an understanding of what the average amount of points is for each category in this case, and we also get an understanding of spread. So each of these tails represents the maximum and minimum value for each category. And then it also shows the density of where all of those points are. So most of the points happen between probably like 4 and let's say that's like 7 or 8 in this case, and that's represented by the box itself. And the biggest amount of that density is around 5, where this dark line is. And then for tall, the minimum number of points is like 11 or 12. That max number is closer to 20. And the majority of the density of those points are happening between like 14 and maybe like 17, with the average being about 15. So we do see some tentative evidence that tall people score more points than short. This is also demonstrated by the lack of overlap in the tails and in the boxes themselves. So we can be fairly confident at this point that there's some evidence that we're moving in the right direction with our hypotheses. Okay, so there are a bunch of different ways you can create these graphs in R. This box plot function is base R. So let's make a note of that, base R. This function is from ggplot. ggplot is part of the tidyverse, which is a universe of packages that all follow the same stylistic guides and the same sort of notation. So it's really easy it's very human readable, really easy for you to use. Most people are going to be operating in the world of ggplot. It's a bit more complicated, but we're going to have a whole separate lecture on that here at some point. But b-ball is going to be the first argument in our ggplot function. There's going to be 3 different layers. So that first layer, and in this case, actually, we're only going to use 2 layers. That first bit, we're going to just be selecting our data. The second bit, we're going to be using an aesthetic layer, which tells which is our dependent and our independent variable. And this is so intuitive, right? Because our x, or independent variable, is height, and our y, or dependent variable, is point. So we've already used that language of x and y before, so that should make a whole ton of sense. This fill argument actually just gives us a color. So you'll see in a second how it picks out color, and I want to fill the color based on the different heights. So that means there's going to be a color for short and a color for tall. And then I want my last layer with the plus sign, moving it down to the next line, is going to be selecting what kind of ggplot I want to use. So this is going to say geom box plot. So you don't have to indent exactly in this way. Make sure you still have all of the parentheses together. So if you ever are struggling and it says that you have an open parentheses, you can click on that and see where it attaches. So you can see if I click here, it's attached over here. If I click here, it highlights it over here. So you know that all your parentheses are closed. You have to use the plus sign, and then you'll add geom box plot. And when you run that, it's going to create a beautiful box plot with 2 different colors. And then you'll be able to kind of more concretely see this association between points and height, right? So the taller you are, the more points you're going to score. So I'll give you a tiny little primer here on inferential statistics as well, in that the box plots kind of are telling us what's happening with the descriptive findings, but what if we want to see if this finding is generalizable to other basketball players? We then are going to kind of move into this world of inferential statistics, and we're going to move into doing z-scores by hand here in a second. But if we wanted to kind of start to look at that in this context, we'll use t-tests. So t-tests let us see if there's a difference between these two populations and if it's statistically significant. So this t-test function is a part of base R. So it's going to use this same notation with our dependent variable on the left, our independent variable on the right, and our data selection. And we won't do linear regression here. But we can see if we run the t-test, we're going to look at our p-value. So the average in the short group is 5.14. The average in the tall group is 14.85. And we can see that this difference, because this is less than our significance threshold, which we'll talk about later, we can be pretty sure that there is a significant difference, or there's a meaningful difference between the points garnered by a tall person and a short person. And so that's the kind of world where we start to move away from just our descriptives and move it to the sort of world of inferential, where we can talk about whether there's a meaningful difference between those averages. And so right now, I want you guys to kind of focus on this section right here, right? So make sure that you've got this part down pat. But then when we move into this next part of the module, we're going to start to kind of think about this world of inference and whether or not we can say that there are meaningful differences between the concepts that we care about in this particular statistical framework.